AC circuit containing resistance only. My dear student, in the very first video of this chapter, when introduction of AC has been given, I have specified that AC circuit can contain three components, that is resistance, inductor and capacitance. Now we will study turn by turn the behavior of these three components to AC, means how does these three components affect AC. So first one is AC circuit containing resistance only. For that we have taken a source of alternating EMF which is connected to a resistance R. Okay, so in that case the EMF E is given by E naught sine of omega t, right? Now we know that when EMF E is applied to a conductor having resistance R, so some current I is flowing through it. In that case, that EMF should be equal to IR, which is equal to E naught sine omega t. Okay, so from here we can say that I is equal to E naught by R sine omega t. Fine. So if we compare this, what will be that? E naught by R is voltage upon resistance. That could be written as I naught sine omega t. According to Ohm's law, this is voltage upon resistance. Ohm's law was for DC circuit. Since for DC also E naught, this is V upon R, and for AC it is E naught by R, constant value again, है ना? So in that case we can say this is the maximum value of current. Now if we compare this equation with this equation, we can see that this is sine wave and this is also wave, sine wave having same frequency and time period. So we can say that in case of an AC circuit containing resistance only, both voltage and current will be in the same phase. About the phase we have already discussed very clearly in our 11th chapter, which is the phase relationship between the two waves. Okay, so since there is no phase difference, there is no phase angle, so we can say that current and voltage are in the same wave. So if we can draw the wave representation of voltage and current, so we can say that if this is the voltage, okay, since this is a sine wave, since this is the voltage E naught, okay, so we can represent current as by this, but having same time period and same frequency. Amplitude may vary. Okay, so that is why we have written it in a downward. This is I and this is E. Okay, so and similarly we can have a phasor diagram. Phasor diagram is basically a diagram which represent the phase relationship between the current and voltage. And how would we draw it in that case? Since both are in the same direction, so this E and this I, this is I and this is E, both are at an angle omega t, right? So in this case this arrow represent the length of or magnitude of the amplitude. Okay, since E is here, it means it is greater than I. Since both arrows are along the same direction, so we can say that both are in the same phase. So from all these discussion we can say that similar to DC, how does this resistance affect? It will affect AC also, means resistance R will reduce DC as well as equally. So the key points for this topic is resistance R reduces DC as well as AC equally. I and R both are in same phase. Okay, so these are the key points which we have to keep in mind for the further derivations of this chapter.